Hello students. In the first part of Heron's formula, we looked into what is Heron's formula, when to apply Heron's formula, and we also solved some questions from exercise 12.1. We move a little further. Let us solve few more questions from exercise 12.1. I want you to keep your notebook ready and jot down the solution as and when we are explaining how it has to be done. Please have a look. This is question number 6 from 12.1. An isosceles triangle is having perimeter 30 centimeter and each of the equal side is 12 centimeter. You have to find the area of the triangle. Drawing the triangle is not mandatory. I have drawn it here so that there is better understanding. Now the two congruent sides are AB and AC, which is 12 centimeter each. You have to find out first side BC because the perimeter of the triangle is given. And after you calculate the length of side BC, you will be using Heron's formula to find out the area of the triangle because the three sides are known to us. So first and foremost, calculate the value of BC. AB plus AC plus BC is 30 centimeter. Substitute the value of AB and AC and then you get the value of BC as 6 centimeter. So BC is equal to 6 centimeter. Here you cannot use the formula half into base into height because the height is not mentioned. So the first step in finding out Heron's formula is calculate the semi-perimeter. That is, what is the value of S? Semi-perimeter, you're aware, is perimeter by 2 or sum of all the three sides, divide them by 2. So A plus B plus C by 2 or perimeter upon 2 and you get the answer as 15 centimeter. So 15 centimeter is the semi-perimeter. Then we have applied the Heron's formula. You're aware of the formula. Substitute the value in this formula. So 15, 15 minus 6, 15 minus 12 and 15 minus 12. So this is what you get. And I have mentioned this earlier. You are not going to multiply these numbers because then calculation becomes little cumbersome. Split it. Now square root of 9 you know is 3. So 3 comes out. Square root of 3 into square root of 3 is 3. Okay, so 3 into 3 you get 9 and 15 comes under the square root. So the answer is 9 root 15 centimeter square. So the area of this triangle ABC is 9 root 15 centimeter square. We have solved it by using Heron's formula. This is the third question from exercise 12.1. There is a slide in a park and the slogan on this wall is keep the park green and clean. This entire area is painted in blue out here. You have to find the area painted in color. So look at the triangle. Three sides are known to us: 11 meter, 6 meter and 15 meter. So here I have taken A as 15 meter, B is taken as 6 meter and C is taken as 11 meter. I have mentioned this even in the earlier video lessons. You can take from these three any of the value as A, B and C. It is not compulsory to take A as 15 only. I could take A also as 6 meter out here. Okay, because I'm not named the triangle. You can take A as 6 meter, B as 11 and C as 15 meter. You will get the same answer. So, area of the triangle, we're using Heron's formula. But before that, calculate the semi-perimeter, which is A plus B plus C upon 2. So it is mentioned out here. And when you solve it, you get it as 16 meter. You can write the formula after this also. So it depends on you how you want to present your answer. You can start off with let A equal to this, let B equal to 6 meter, and let's see equal to 11 meter. After that, write down the semi perimeter, find out the semi perimeter, and then mention the area of the triangle using Heron's formula. So this is a continuation. So this is the value that you get after substituting A, B, and C. 16 into 5 into 10 into 1 meter square. Take out the square root. Root 16 is 4. So these steps which are mentioned here, you can skip them and directly write root 16 is 4. Then 10. 10 is expressed as 5 into 2. So you have root 5 into root 5, which is 5. So that 5 is written here. And 2 remains. So that goes under the square root sign. So root 16 is 4. 10 is expressed as 5 into 2. So 5 comes out because root 5 into root 5 is 5, and then root 2. And then you get the answer as 20 root 2 meters square. This is the area of the triangle. So the area painted in color is 20 root 2 meters square. Please make a note of this solution and also the question number. Now let's look at another problem from exercise 12.1. This is the second question. The triangular side walls of a flyover has been used for advertisements, and the sides of the walls are mentioned out here. The advertisements yield an earning of 5,000 per meter square per year, and a company has hired one of its wall for 3 months. How much rent did it pay? So what does this question mean? This is a triangular wall on the flyover. So a company has hired this portion of the wall to put in their advertisements. So obviously nothing comes free. You have to pay rent for occupying so much of space. And the cost here is for 1 meter square, they are charging you 5,000 rupees for a year. But this advertisement which is displayed is going to be kept only for 3 months. And how much you have to pay for the advertisement depends upon how much of space you have taken of that wall. So obviously you have to calculate the space occupied here. That means how much of meters square of space is taken. That means you have to calculate the area of triangle ABC. More the value or bigger the area of the triangle, more is the amount that you have to shell out. So we will calculate first the area of triangle ABC. These are the three values given. 120 meter is from A to B. From B to C it is 22 meter, and this distance from A to C is 122 meter. So write down what is small a, small b, and small c. I've mentioned this before. The side opposite to capital A will be small a. So BC will be small a. That is, small a is 22 meter. Then the side opposite to capital B, that is AC, will be small b, which is 122 meter. And the side opposite to capital C, okay, that is this AB, will be small c, which is 120 meter. Use the semi perimeter formula and we get the answer as 132 meter. This semi perimeter, apply it in Heron's formula here, substitute the values. So once you substitute the values, this is what you get: 132 into 110 into 10 into 12. I mentioned this before, do not multiply these numbers, split it up. Now the clue is in this step itself. 10 into 12. So 110, I can write it as 11 into 10. 132 can be split as 11 into 12. So 11 out here and 11 out here. Then you have 112 here and another 12 here, and 110 and another 10 out here. So split these four numbers. We have expressed 132 in this manner, 110 in this manner, and 10 and 12. You can also solve this in a different method. You can write it as a product of its prime numbers also. So take out the square root. Root 11 into root 11, 111 comes out. Root 12 into root 12 is root 144, which is actually 12. Then root 10 into root 10 is 10. When you multiply these three numbers, you get the answer as 1320 meters square. That means the area of this triangle is 1320 meters square. So that much of space we are occupying, or the company is occupying for the advertisement. Now, 5,000 rupees is for 12 months. That is a rate. For 1 meter square, it is 5,000 rupees for 12 months. For what? For a year. So for 3 months, how much will it be? X. So you cross multiply. That is 5,000 into 3 by 12. So rent of 1 meter square area for 3 months is 5,000 into 3 by 12. So you can omit these two steps. You can directly write this. You can mention this before this step. So this is the amount that you have to pay for 1 meter square of area for 3 months. But then what is the answer? It is how many meters square? It is 1320 meters square. So for 1320 square meter of area, how much you will have to pay? This you're going to multiply by 1320. Solve this portion. When you solve it, this is the answer that you get. That is 16,50,000 rupees the company has to pay for that part of advertisement for 3 months for choosing for an area of 1320 meters square. I hope this solution is clear to you. Please make a note of this in your notebook. This is quite an important question. Okay. Is Heron's formula required in these triangles? You've already learned in the first video lesson when to use Heron's formula. In this triangle, the base is A and the height is H. So when the base and the height is given, you need not use Heron's formula, directly use half into base into height. Same is the case with this. It's a right angle triangle, so it is half into product of the perpendicular sides. Here also the height is given and the base is mentioned, so Heron's formula is not required. Now here, the three sides are mentioned, but at the same time the height is also given and the base is also given. So you may as well use half into base into height, where the base is A and the height is H. In case you use Heron's formula in this, you will get the same value. This is an equilateral triangle because all the three sides are equal. So in these four figures, Heron's formula need not be used. You just have to use the formula half into base into height. Now this is a homework from 12.1. Find the area of a triangle, two sides of which are 18, 10 and the perimeter is 42 centimeter. We've done a similar question. Now this is an extra question which I have given along with a hint. The three sides are given. Use Heron's formula. You will get this as the area. Then they have asked you find the length of the longest altitude. Altitude is the height. You know that the longest height will always lie on the smallest base. So the base will be the smallest value among these three. Base is 35 and height is h, because you don't know the height. You have to calculate the height. But the area remains the same. Area of the triangle you have already calculated by Heron's formula. So 420 root 5 equal to half into base into height. And from this you will get the height, which is 24 root 5 centimeters square. Clue is given out here. I've also mentioned the answer. Work it out and see whether you're able to solve this. Okay. In the next video lesson, we will be doing 12.2. Until then, goodbye and take care.